Alright, more streaming. I watch streams all day, so maybe somebody's interested in this kind of stream. I cannot show you the vector robot today because I sold it. I sold it at a profit. I sold it used and it's worth more than I paid for it. These robots are like little value things. They're kind of rare, I guess. There are not many alternatives. And Vector is a great robot. I was just getting tired of it repeats after a while. Vector recognized my face and everything, but it didn't learn as much as I wanted it to learn, so I sold it. I'm so cruel. Anyway, we are making new chatbots. I launched like 3 chatbots in the last weeks, and we can check these out quickly. For example, here. Oh, we don't have a voice input field here. That would be a great addition. It's not hard to make, I can do that. For now, we have to type the old way. This bot schedules meetings. How about Wednesday? Yeah, it gives me some dates. I can choose a different date. I can accept. And I can give my name and a phone number. I will get an SMS. And the meeting is scheduled in Google Calendar. And you can get this same kind of chatbot for your homepage. This is one of the nice new projects we made. I'm glad the demo works. It's always good when demos work. And here is a little chatbot. What is the trial option? And so on, if you want to learn how to extract teeth. And this is a bot for actual legal documents. It's a whole service. It takes you through a list of questions. It's quite a few questions because that's the nature of the thing we're making. It's a general terms of service document. And you can click and you can type. And yes, we want to continue. My company is called Super Company Limited. And I do not have a short name. And my phone number is 123. Oops. Now, of course, this is the phone number. And when you're through with all this, you will get a Word document that's perfectly formatted, contains all the right sections and your data in it. And that's a service we also made. And lastly, my cruddy is slowly, very slowly progressing. I'm still hunting for this always on mode. It has an always on mode now, which means, and it has a good sound too. Listen here. Hello world.
Hello world.
Stop listening. The sound you heard means that it's streaming to the cloud. I wanted some auditory feedback to tell you whether you are being listened to by Google in this case. So that sounds means exactly that. And the point is here that if you stop talking for a while, it will turn off the cloud connection. And if you make any kind of voice-like sound, it will turn it on again. There's a little voice activity detector in it. So you can basically leave it running all the time, like Alexa, and talk to it at any time, just through the browser. It has promise. This really has promise. We need to put in support for other browsers and some actual functionality and whatever. There's a Google login here too, so it can connect data to your Google account. So that's where things are going. And today I want to code some stuff. I want to code a really fast text index. Make a ridiculously fast full text index. We are searching my code base, my whole repository. The old school search I have is in MySQL, and this is how long it takes for a search. to put in multiple words, it takes longer. And I want it faster. I'm not happy with 0.3 seconds. It slows me down. I mean, it doesn't really slow me down, but it's a fun thing I want to make. Just some dreams I've always had. I want to realize them. And one of them is a really, really fast search over a big body of text. Where is the actual cache? Here, first it loads all the text into memory. We have 46 million or 47 million bytes or characters. So we could search that directly. Just scan these 47 megabytes. Oh, what is that? We didn't see that. Here. If we scan these directly, we get something like 8 milliseconds, 4 milliseconds, or it gets slower when you have a longer string. This is looking for the whole string, not two words in somewhere, just this exact string. If you look for something that's not in there, it still takes 41 milliseconds. And as I said, I want faster. So next idea was to make a word index. We take everything that is a word and make an index of that. So you can, if you know the word you're looking for, it is one single map lookup, which is just damn near instant. If you're looking for a part of a word, it has to scan this whole list of 220,000 words, which is not instant, but should still be pretty fast. So with this word index, if we tweak it a little, we could get really, really fast. I already have search that is using this index. And you see I show the sub-millisecond timings now. So through the word index, it takes 5 milliseconds for the search. That's pretty good. But I still want faster. What's the logic here? If we have a sentence like this is cool, we're looking for this string in all the code snippets. Then what do we know? We know that this word has to appear in the text because we know what comes before and after it. So this we can directly look up in the index. That's instant. What do we know about this one? We do not know that this word appears in the text because left of it there could be another letter. It's unlikely in this case, but there could be another letter. See how fast this was? Instantly found out that one of these words doesn't even appear. And boom. Did it? How does it do that? It shouldn't. I didn't program that yet. I don't know. It's going to be interesting. How did that work? Because the point is, yeah, as I said, here we don't know what comes before it, so we have to scan the whole word list for any words that end with this, which is not absolutely instant. And oh yeah, but I know I know why it was so fast. What do we know about the last word in the sentence if there's not a symbol after it? We know that there's a word in the text that starts with cool. And the way this index is made, we can find that instantly. The list of words is sorted, so we can find any words that start with cool in just about an instant. But we see here that this is not instant. I think, and I know why. It's because it goes through all the words in the query and looks at each of them separately, and this is expensive, so it makes an expensive list of potential results. And then later it finds out that that was not necessary, and it just could have gone with this simple thing here. So I want to improve that a little. So where are we here? This is the cool search function. How about we comment it a little? Go through words in query. So we would do different things here. We would switch to an iterator, which means we don't return a whole list of results. We just return a function that you can call to get results. Because in the user interface, there's a limit of 1000 results anyway. And why make a list that's longer if you're only going to show 1000? And this is the expensive thing. We go through the whole word index and collect all the results that might be what we want. So we would change these. There's one more really clever thing we can do, because the index has a word that points to a list of snippets, list of texts. And if we sort these snippets in some way, we can make the intersection of multiple results really quickly. Nobody understood what I just said, I guess, but the point here is data structures. We make a tree map that points to a tree set, so we have sorting in every step. And sorted data is usually a lot better. So maybe I'm not going to code this on stream right now. Who's going to want that? But I think this could be made super, super fast. Virtually all searches you can do in sub 1 millisecond over this 50 megabyte-ish code base. So beating Google step by step using fast searches. Yeah, I'm not going to code this right now. I just want to give this quick update about stuff I do, get back into streaming.